And we are live. Sid, welcome to the crazy house, I think. Depending on who we get in the chat, we often have carnage in the chat here as well. So hopefully everyone will let us know if they can hear us as well and everything's okay. Sid, why don't you introduce yourself to everyone? Because you're probably, I'd say you're actually, yeah, we don't usually get people from so far away over the water speaking here as well. So it's excellent to have you.
Sure, yeah. So my name is Sid. I'm a software engineer by trade. I live in the United States outside of Boston, Massachusetts, and I am a consultant in the DevOps and cloud infrastructure space. So I basically help startups as they start to find their product market fit and their business starts to grow. And a lot of those systems that they've put in place for dealing with developing and deploying their applications start to break down, both in terms of as the team scale and as the number of users scale. And so what I'll come in and help them do is figure out where we can automate certain things, where we can streamline processes, and how to improve their cloud deployments so that we can handle as much scale as their customers are going to bring. And so that's what I do. I also run a YouTube channel called DevOps Directive, where I focus on sort of producing both informational content as well as tutorials to help engineers level up their DevOps and cloud infrastructure skills. So I've been around since about February on YouTube, and it's been a slow journey, and then in November I had a pretty good month, and now I'm up to almost a little over 7,000 subscribers. So it's been a lot of fun and continuing to get better with each video that I put out.
Nice. And it's great because I think there's a lot of us now that support each other as well, that are in this craziness of also kind of consulting, running businesses, and then also trying to teach people on the side. So what kind of drives you to, I suppose, spend a lot of your free time on making content as well?
Yeah, I've always found myself to enjoy the act of teaching, and it's both fun to see the results of having a student learn something new, but also the process of building out that content and learning it deep enough to teach it in a clear and intuitive manner helps me to solidify my own understanding as well. And so I actually started my YouTube channel when I was in a break between two jobs. I was coming off of a full-time role where I was a bit burnt out, and I knew I wanted to take some time off before jumping back into the job market. And so I decided to start DevOps Directive as sort of a way for me to continue learning and building and teaching. And then it's grown into both this mixture of content creation with my consulting work. And so now I'm doing that full-time, split between those two buckets.
Nice. And you were saying earlier that it's scaling businesses and kind of team hiring and everything else. Do you have, what is the most difficult part of that role? Is it the technology or is it the people? Because I think depending on who you're talking to, I might get different answers.
Sure, yeah, I think it's always going to be a blend where you can't assess either of those independent of the other. Your team is what's building the software, and so you need to understand how they're going to interact with the software, how adding a new member is going to change the dynamic of that team. And so a lot of what DevOps is all about is sort of not only these tools and technologies that people tend to focus on, but also the practices of how we communicate as a team, how we get data off of our software in production to understand how it's operating, and how we feed that back into this closed loop cycle so that we have kind of a human in the loop system.
Nice. That makes sense. So the DevOps Directive, I actually put this on, let me try this. I had a little banner made up before this, so I'm going to see if I can stick this to the screen as well. Make sure you subscribe to DevOps Directive. Excellent
awesome,
content.
Yeah.
I've been looking at some of this stuff myself to refresh myself, because I'm definitely more of the builder in the sense of building the logic and things, and then I always scramble madly at the end to go, oh crap, why isn't it scaling? So this is something I need to get better at personally, and I'm really excited for everyone else to get involved in this. And I suppose you might as well give an overview of what we're going to go through today as well.
Sure, yeah. So we're going to essentially look at a sample DevOps workflow. There's tons of different things that DevOps can mean to different people. And so what we're going to do is take a very, very simple website. I'm going to have it on my local system running. And then I'm going to containerize it with Docker. So that allows us to take that website, put it alongside a web server inside of this sort of bundle that has all of the necessary dependencies to run it. I'm going to take that container image, and then I'm going to deploy it to a virtual machine running in DigitalOcean. I'm going to hook up the DNS so that we can actually visit that website at kodu.mysuperawesomesite.com once this presentation is over. And that website actually is the same as my presentation. So it's kind of a full loop here. We're going to build the presentation while we're deploying it and presenting all in one.
What could go wrong? As I said, what was in the description? Build a plane while flying it?
That's right. That's right. So we're going down the runway now, and we're hoping the wings are going to be attached by the time we get to the end. Yeah,
well, let's see how it goes. And if you have any questions in the chat during this, make sure you ask them. I'm going to ask whenever I can for you when Sid has time to answer them. And I'm sure at the end, Sid, you'll have hopefully a few minutes as well to take any, even if it's career questions or anything like that, because I'm sure for a lot of people, they might be just wondering how to get into a DevOps career. And
definitely,
although they'll have some of the knowledge here, I think there's also some of those soft skills that are very important that we can talk about at the end.
Perfect.
Yeah, let me bring up your screen here. Excellent. So take it away.
Okay. So we've got a browser up with a presentation running. And so this is going to be, like I said, just a very high level flyby of a lot of DevOps concepts. We're not going to go too deep on any of them, but we will have time to sort of poke at it and ask questions and demonstrate things along the way. And so this should hopefully just give you a taste of the different types of tools and technologies you might use when you're working and thinking about DevOps, and know what to search for to learn more. So how does AWS define DevOps? They define DevOps as the combination of cultural philosophies, practices, and tools that increase an organization's ability to deliver applications and services at high velocity. Now, that's a lot of that's a lot of words, a big mouthful. We can really just condense this down, though, into figuring out how to empower developers to build new features and how to deploy the software that they're building in an effective and reliable way. And so anything can fall into that bucket. People think about a lot of different tools and buzzwords. People talk about continuous integration, continuous delivery. They talk about virtual machines and containers. Docker is a key concept and buzzword when it comes to DevOps. So many tools people lump into this DevOps bucket. And so really, as you look at your software development lifecycle, it's all about figuring out where these tools and practices fit to make your team better, faster, and more reliable when it comes to building and deploying software. Like I said up front, the agenda for today, there's really only one high-level bullet point. We're going to build and deploy this exact presentation. Like I said, it's running in the browser. The presentation is just a website. So we've got this HTML file, we've got some JavaScript in the background, a few images, and that's going to populate the presentation for us. We're going to break it up into 3 main components. We're going to start with just the raw markdown file. That's the data itself that represents these slides. We're then going to grab the JavaScript dependencies, and we'll serve that locally. So it'll just be a website running on localhost, which is what we see here that I'm actually already doing. So we're going to walk through to get to the point where we're at. That'll be part 1. That'll be pretty quick. In part 2, we're going to take that very simple website, and we're going to Dockerize it. We're going to build a container image with a web server called Caddy. We're then going to create a virtual machine on DigitalOcean and deploy it to, this was from a previous presentation, but this will be kodu.mysuperawesomesite.com will be the actual domain that we deploy to. And then at the end, I think we should have time that in this 2-hour block, we're going to set up continuous integration, continuous delivery with GitHub Actions so that any change we check into our GitHub repo will automatically be built into that container image and deployed to the virtual machine. So that's the agenda for today. I've broken it down in a little more detail here. We can see our 3 main parts. And so without further ado, I think we can just go ahead and jump into it. Any questions up front before we get started now?
No, I think we're good. A lot of people just excited to be here. I've been pinning up on the screen.
Awesome.
I think a lot interesting topic. And it's great that you can pack this much into one session. So I'm really excited as well.
Definitely. So I've got my IDE up here. I'm using VS Code. And my directory structure is pretty simple to begin with. I have this one markdown file that contains the underlying data for this presentation. Pretty simple, just basic markdown with a couple of formatting tags that are specific to the JavaScript I'm going to use. I then have these images, which were the ones used in that first chart in terms of my headshot and other images. And so the very first step that we're going to do is we're actually going to go to the JavaScript library that I'm using, which is this remark JavaScript library. It basically takes a markdown file and turns it into a presentation. And so I'm just going to copy this boilerplate here, like so. Should be fine. Then we're going to just create a index.html, paste it in.
That's remark.js remark, isn't it, on GitHub? Just so I can paste it into the chat.
I think it was this gnab/remark was the URL. And so they have here defined within their HTML file this introduction, all the markdown inline in their HTML file. And that's fine, but we're actually going to pull it out into a separate markdown file. But first, why don't I go ahead and serve their boilerplate code just so we can see what it looks like. And the easiest way to do that for me on a MacBook is just to do Python 3 -m for module, HTTP server, and then the default is to serve on port 8000. And so now, if I go back to my browser and go to a new tab on localhost 8000, oh, what did that happen? So the reason that happened is that I started that web server from this top level directory. There's no index.html in that directory, so if I go into the presentation directory and then run my web server, now if I refresh the page, I get my nicely formatted markdown with the boilerplate code in it. So title, agenda, introduction, that corresponds to this content here within the body of my HTML. I'm going to just get rid of that, and instead we're going to reference our source file within this remark.create call. So we can just pass in a source URL, and that is going to be named markdown.md. Save. OK. Cool. So now if I refresh, it should pull in my markdown. And now we have my presentation back here in the browser on port 8000 from that Python web server. Just for cleanup purposes, to keep things separate, I'm going to pull out these styles. Again, they've just defined them in line for convenience, but I'm going to get rid of them here and then create a style.css. I'll paste those styles in. I'll fix the indentation, save it, and then we're just going to add a link to that style sheet like we would any other style sheet in an HTML document. And so that will be link rel equals style sheet. And then we need to point to that file with an href equals styles.css. Then I got to close that. And so unless I made a typo, which is entirely possible, we should refresh and get identically the same thing. All right, so we basically made it through part one. We took our markdown file, which was that baseline data. We pulled in that JavaScript library. We cleaned it up a little bit by separating out our markdown file and our CSS file. And then we're using a Python web server to serve it locally. Now this is fine for development purposes. We can make our modifications, get everything looking how we want it. But that Python web server is definitely not production ready. There's a number of issues with it that we don't need to go into here. But we want to find something to use that will be a much more secure and performant web server that we can use to actually serve this thing on our virtual machine in the cloud. There's a number of options for this. We could use something like Nginx, is a hugely popular web server that is very high performance. I'm actually going to use a different web server called Caddy. Caddy is pretty cool. It has a number of nice features. The one that stands out, though, is that it automatically sets up our HTTPS included in the web server itself. So if we used Nginx and we wanted to have a nice SSL cert with a secure connection, we would need to then go off and add some other tool to our architecture to provision that certificate, etc. Caddy has all that built in, so if we just configure it correctly, it will go off and provision a TLS certificate and give us that HTTPS out of the box. And so that's why I'm using Caddy.
That stops some of my biggest frustrations straight away, is setting up those certificates. So
yeah,
I've never actually come across Caddy. That's excellent.
Caddy is nice. I was using the first version of Caddy for my DevOpsDirective.com site for a long time. I have since moved it to being hosted in a Google Cloud Storage bucket, but it works quite well for a number of purposes. And it's very simple to configure it as like a reverse proxy and a number of other use cases. So it's definitely a cool technology and tool.
Nice.
All right. So now that we've got that all running, let's go ahead and jump into creating a Docker file that's going to contain both the content of our website and that Caddy web server. So I'm going to create a Docker file at the top level of my directory. And that is going to start from a publicly available image. So oftentimes when you're building a Docker file, you're going to start from either like an operating system base image, so it might be from Ubuntu or from Debian, or you can find a publicly available image from an organization. In this case, we're going to look at the Docker Hub for Caddy. So this is built from the same people who are building the web server itself. They've put together this official Docker image that we can use. We see all these different versions. They've built it with different for different architectures, some of them for Windows Server, some of them for Linux. And I'm just going to use the 2.1.1 tag. That looks like the latest version, and so that should be fine. And so the syntax here for the Docker file is just going to be something like from Caddy 2.1.1. And so that will bring in that base image, and then I'm going to build on top of it. And so if you haven't used Docker before, each line in the Docker file gets executed sequentially and sort of adds more content to the file system that it's building up. And so we want to order these things in the order that is least likely to change. And that's because Docker has some really nice caching, such that if you make a change, you only have to rebuild steps that happen after that change. So in this case, I'm going to copy in what's known as a Caddy file that I haven't actually created yet, but I'll create here in a second. And a Caddy file is how we configure Caddy. Caddy by default looks for that in this etc/caddy/caddy file is the location that it will look by default for that file. And so now I'm going to go ahead and define that here, Caddy file. And there's lots of different options that you can include in this Caddy file. Here we're going to keep it super simple. We're going to define a http://localhost 80. So this is the domain that Caddy is going to serve on. In this case, this is just setting it up to run locally. I'm going to specify root */serve. And so that's saying within my Docker file, look for files at the /srv directory, because that's where we're going to put our website files. And then we're going to use the file server directive. And so this just specifies Caddy looks at that directory and will serve up as a web server any file within that within that /serve directory. Okay, so that looks good. So we will copy that Caddy file into our container image. Once we do that, we need to copy in the presentation itself. So we'll do, again, copy /presentation, because that is where all of my files for the website presentation live. And we're going to copy that into this /serve directory, which is the same directory that I specified in that Caddy file, right? So that's where Caddy is going to look, and that's where I'm going to copy the files. And then finally, I'll expose port 80 from that container. So when I run the container, I want to have port 80 open and listening for inbound requests. Okay, cool. So that should give me the baseline Docker file that I need. I'm then going to build and run this container. So I'm going to kill my Python server down here, and I'm going to do Docker build. I'll use the -t flag to tag this image with some name. So I'll just name this presentation, and then a period specifies that I should build from my current directory. And I just realized that I am one path down, so I'm going to go up a level with cd ... and run that again. And so now my Docker file is being built into this container image. So we see it went through each of those steps within my Docker file. It started with that base image, copied in my configuration file, copied in my presentation, and then exposed port 80. And again, the reason that I did this in 2 steps instead of 1 is so that if I modify the source code of my presentation, but not my Caddy file, I can take advantage of that caching so that I don't have to rebuild that step. In this case, it's not a huge deal. If you're bringing in, let's say if you're working on a Node.js application, you would almost always copy in your package.json and your yarn.lock or your npm.lock file first, then run your installation of those dependencies, and then finally bring in your source code. That way you don't have to reinstall all your dependencies with each change to the source. Okay, so we have that. Now I'm going to run this container locally on my system. So to do that, I can just use the docker run command. I'm going to port forward, so that -p command is going to forward a port from my local host, so my MacBook, into that container. So I'm going to port forward port 8080 on my MacBook to port 80 inside that container. And then I just need to specify the tag that I used before, which was this presentation tag. So that should be running. And now if I go to port 8080, we should see our presentation running inside that container. And we do. So we didn't make any mistakes yet, which is awesome. Just so if you're not familiar with Docker, there's a lot of things we can then do to look at this container. We can do a Docker PS. We'll list all running containers on your system. And so here is that container that we just launched. We can do Docker logs and then specify this container, and that will give me the logs from that container if we needed to see something going on. If we wanted to have a live shell inside that container, let's say we needed to poke around and figure something out, we can do something like docker exec-it will give us a interactive terminal inside that container. We'll paste in this, and then we'll do sh for shell. So now this shell session is actually inside of my container running on my system. So I can see within that directory where I copied my presentation, I can see all these files, etc. So those are just a few sort of basic Docker commands that you'll become very familiar with as you start working with Docker. You'll be building these images, running them, examining them live, potentially hopping onto a shell session within them to figure out what all is going on. So I'll exit out of that. Go ahead.
Quick one for you, Sid. I suppose for anyone that isn't familiar with Docker, what is the difference, I suppose, between having a virtual machine and using something like Docker instead? Like, obviously we see how lightweight it is here to throw up and get things going, but is there any big differences people should know about?
Yeah, I think the main difference is the level at which you are virtualizing. So a virtual machine, you're virtualizing the whole stack, sort of, including hardware. Containers, you're only virtualizing the software layer. And so I've seen some good images of this. where it shows, yeah, so basically with a virtual machine, you have each of these guest OSs running within your virtual machine. With a container, you're still just running one OS, and you're isolating things within that OS, and you can have different you can have a layer of isolation that doesn't require you to virtualize that whole operating system like you would in a virtual machine.
Cool.
And so that enables you to have a much lighter weight end result. That allows you to spin them up and spin them down faster. You can put many of these things, more of these things on a single physical host because of that. And it then allows you to use tools like Kubernetes or Nomad, etc., and orchestrate many of these containers, whereas it's a little harder to do with virtual machines. It's not impossible, but it's just a little more fluid when you're working with containers.
Okay, excellent.
Cool. So let's go back to our code editor. Actually, let's see how we're doing on our checklist here within our presentation. We have done all of this. One thing I will do now is to create this makefile. And so I love makefiles. They allow you to store off commands that you're going to use later. So rather than having to memorize all these Docker run commands and type them out in full each time, we'll just save them off as a make target within this makefile, and then we'll never have to remember them again because they'll be there ready to go for us. So I'm just going to do make. And so this is a Unix tool that's been around forever. I don't know that there's an equivalent on Windows. You could probably do something similar with PowerShell, or you could use Windows Subsystem for Linux, and then you would have make available to you there. But for example, let's add a build target. So we'll do build local, and this will be that command that we ran earlier. And then we can do run local. And so now, instead of having to run my Docker run command each time, I'll just run this build local command. And again, I'm realizing that I'm one directory up, so I'm going to run cd presentation and then that Docker build command, and then that should be good. So now instead of doing Docker build, I would do make build local. Oh, just kidding. So I didn't need to make that change directory command because my Docker file was located as a sibling to my make file. And I handled the path here within this copy command inside my Docker file. But now I have these two commands that I never have to remember again, and I can just go and look at my make file and see what do I need to do to run it, to build it locally, what do I need to do to run it locally. Okay. So now I'm going to go ahead and provision a virtual machine on DigitalOcean that we're going to use to deploy this thing to. So I have DigitalOcean pulled up here. I'm just going to get started with Droplet. One nice thing about DigitalOcean is that they have a number of options. One, they're pretty affordable in terms of what you get. I'm going to choose this cheapest $5 a month option. It gives me a gigabyte of memory, one virtual CPU, a 25 gig disk, and 1,000 gigs of data transfer, which is plenty for most small projects. I'm going to go into this marketplace option over here. And so as you can see, I could choose any of these major Linux distributions. That would be fine. But this actually helps set things up very quickly if you're working with Docker, is to use this marketplace app, Docker 19. So this is the latest version of Docker running on Ubuntu. And that's going to have Docker installed. It's going to have Docker Compose installed if you want to use that for multiple services. But it just kind of gives you a nice baseline to get started with. I think all these other options are fine. I'm just going to click create, and it'll take, I don't know, 30 seconds to spin up. I am going to add a firewall rule to this setup. So I'll go here to the networking tab, and I've actually defined this firewall rule ahead of time. It basically allows inbound SSH traffic. So that'll allow me to SSH, connect via SSH to this machine, to send code or whatever to it, send commands to it, like my Docker run commands. I also have an HTTP rule, so inbound requests on port 80 will be accepted, as will inbound request on port 443, which is the port that is used for HTTPS requests traditionally.
So a couple of questions as well in there after. I'll let you finish that thought, and then I'm going to ask you a couple of questions if you're okay.
Yeah, so I'm just going to add that machine to this firewall rule. And so now it should accept inbound requests on those ports. If I didn't set up that firewall rule, by default, I believe that the firewall is locked down and you could only SSH. You wouldn't be able to hit it with an HTTP request.
Nice. First one, can we replace the makefile with a shell script?
You certainly could use a shell script instead of a makefile. The one nice thing I like about makefiles is that each of these can be operated independently very easily. You can do something like that with little shell functions that you call, but by default, these operate independently. So if I have a bunch of small things that I don't necessarily want to run all at once, I like using make targets because I can just call one and it's sort of fully encapsulated what it is supposed to do.
Nice. Next question is there an API to provision without going to their portal?
There is. So there's a DigitalOcean command line tool, I forget what they call it exactly, that you could use to provision these things. You can also use an infrastructure as code tool like Terraform, which is my favorite infrastructure as code tool. Terraform. Ocean. Terraform has tons of different providers. And so here we would set up Terraform, and then there are lots of different resources that we can provision within DigitalOcean using Terraform. So that allows you to define this infrastructure declaratively. And that's a great point from Chris, is that while I am going in and doing this manually, that is not a good DevOps practice. I'm doing that for the sake of time within this presentation. We are using DevOps in the sense that we're touching Docker and we're going to do CI/CD, but we should be provisioning all this infrastructure declaratively within our code. And I did a slightly more advanced DevOps crash course on the Traversy Media channel, where I do provision everything with Terraform. And so that's a good resource if you want a slightly more advanced version of this, where I do some Docker, I provision code, and also use GitHub Actions.
Excellent. The last one is just Sean Kelly on LinkedIn is saying, I'm moving over to DigitalOcean from Azure portal, so this is exactly what he was looking for today. So he's saying
awesome.
Thanks.
Yeah, I haven't used DigitalOcean as much as Google Cloud is generally my go-to. It was really nice in this case because it has that pre-configured Docker option. So I went with it for this particular demo, and I think it does have a nice sort of getting started experience for people onboarding. Whereas something like AWS, you get into their control panel, it can be a bit overwhelming as a beginner. DigitalOcean has many fewer offerings, and so it's easier to figure out, okay, here are my virtual machines, here's my data volumes, here's my databases, etc. So it's a little easier to get started, I think, on DigitalOcean than something like an AWS, which can be overwhelming.
Totally agree. That's where I learned to provision everything myself. Was on DigitalOcean when I had no clue how to even SSH into a machine. It was all through here.
Nice. There's one more setup step I'm going to do for this machine, and that's going to be to set up my DNS. So I have this domain, mysuperawesomesite.com, that I own. Go to it, check it out. It's pretty awesome. And I'm going to add a subdomain for that, and we'll just do kodu, and then we'll point it to the IP address of my machine that I just provisioned. The app is not running there, so if we go to kodu.mysuperawesomesite.com, nothing happens. I think I have it pulled up here. We're just going to get no response. But in about 30 minutes, we will have the site running there live. Okay, so we've done a few more of these things. Create a Docker Hub repo. So we just built and ran this Docker image locally and then ran the container locally. In order to get that image onto our virtual machines, there's a couple of options. We could push our source code to the machine and we could build it there, but that would not be a very good practice. Instead, we want to build our images likely within a CI tool like GitHub Actions or Circle CI, and then we'll push them to a registry where our virtual machine can pull from. The most common registry is Docker Hub. It's the same place that I found this public Caddy image. And I have a profile here, Docker Hub /Sid Palace. And I created this repo ahead of time, Kodu Intro to DevOps. So that is going to be the repository where we store different versions of our image. So that's where we're going to push to. And then when we run it on the machine, we'll pull from that repository and run it. So that is good. Now we need to change our Docker file and our Caddy file slightly to set it up for production. Remember, in our Caddy file, we only specified this local host. We need to specify the actual domain. We need to set it up so it's going to provision that TLS certificate. We also want to expose port 443. So I'm going to copy these over, and we're going to have Docker file, and I'm going to name this, we'll just name this one Docker file local will be the original. And then again, we're going to copy the Caddy file, and that will be Caddy file local. And so then the one with the postfix will be our local version. The one with no postfix, just Docker file and Caddy file, will be our production versions. I do need to then update this to pass -f Docker file.local. And so this is, by default, it's just going to look for a Docker file with no postfix. By passing this -f flag, it will then know to use this particular Docker file and not that one. Like I said, I want to make one modification to our production Docker file, and that is going to be to expose port 443. I think that is the only change that we're going to need. We then want to modify our Caddy file, and so this one is going to be, instead of localhost port 80, it's going to be kodu.mysuperawesamesite.com. That is the subdomain we're going to deploy to. And then we need to add a TLS directive, which is going to be the email associated with the domain when I purchase that domain, which is just my personal email. So that should be fine. I think that's all we need from that modification. And so now I'm going to build and push to that Docker Hub repo. So I'll do build production. This will be Docker build -t. And I'm actually going to use a variable here because I'm going to use it in a bunch of places. And that's going to be image tag, which I'll define in a second. The file itself is just Docker file, and it's here. And so I can just define a variable, make variable here, and that will be something like, it needs to match the image tag from Docker Hub. So it'll be this guy. And then I want it to be tagged. I'll just tag it. I'll just hard code the tag for now, and it'll be something like latest. We'll modify that in a bit when we add our CI/CD. I'm also then going to add a push production make target. And so push will take my image that I just built from before. I'll do Docker push and then image tag. And so let's go ahead and try these out. I'm going to clear this one just to get it out of the way. Oh, exit. Need to. So I'll do make build production. We see that variable, my image tag, gets substituted in by make before it is executed. So So even though this was -d image tag, it was substituted in with the value here when it ran the command. So that string expansion and when it is happening is an important consideration to understand when you're using a makefile, in case there are things that you want to be basically interpolated at runtime versus at execution, versus when the command is called. So we now have that image locally. And so in order to get that to the Docker Hub, we'll do docker push image tag. Make push production. And one thing you would need to do is to authenticate your user account locally to that Docker account remotely, which I had already done ahead of time. But it's pretty straightforward, and there's instructions on Docker Hub of how to do that. But we see that image was pushed, and now we didn't have any, we had last pushed never here, but if I refresh the page, we should get an image.
I have a question as well when you have a moment as well, Sid.
Yep. So we've got that latest tag that we just pushed a few seconds ago. So that image is now available in that public repository. And so we could then go onto our virtual machine and pull it down and run it. Go ahead now.
Okay, I'm going to pin it to the screen. Is nfile a good practice here to have all configs and load them appropriately into the Caddy file?
So the question is around whether we should separate out multiple environment files. So we could do something like config, and then we could have a local.env and a
I'm still seeing your
oh, sorry. Yeah, I forgot to switch over. There we go. So we could have something like config, although that needs to move up a level. New file, local.env, new file, production.env. That's fine to do. In this case, I don't have any application secrets or anything that I'm trying to keep out of the GitHub repo. And so there's no need for me to do that. You could add sort of variables to this Caddy file potentially, but I think it's easier in this case just to have like these two Caddy files basically represent the two different environments. And so that's why I have them separately. We could have a single Docker file where we inject which ports are being exposed via an environment variable. In this case, I didn't, just for simplicity's sake.
Cool.
But yeah, if you're working on an application, you don't want your application secrets like the database credentials or what have you to be in the code, then extracting them out into an environment file is definitely a good idea. I released a video a few weeks back around sort of the different levels of application credential management. And so of the 5 that I described, that's like level 2. And so there's still 2 more better ways to do it, but it's definitely better than nothing.
So check out that video if you want to figure out what the other 3 are.
Yeah, definitely. Okay, get rid of this. So let's go back to our to-do list and see how we're doing here. So we created our repo, we created a version, we built it, we pushed it. And so now let's go ahead and SSH onto our virtual machine and run that container. So in order to SSH onto the machine, we need our virtual machine IP, so I'll store that off as a variable. And that will be, actually let's just make it our SSH string as the variable. And that will be root at, and then our IP address, which we can grab from here again. And so I'll just add a make target for SSH, and that will be SSH string. Add it to our known hosts. And so now we have a shell session live on our VM, which is exactly what we want. Cool. So in order to run this on the VM, we can do docker run. Let's give the container a name. Actually, we don't need to do that for now. Later we'll add a container name so that we can address it directly. By default, if you don't provide a name, Docker issues a randomized name that combines usually two random words. And so it's harder to address directly. If we name it, then it has a stable name that we can later remove and clean up as needed. So I'll do docker run. I'll do -d, which is to run it as a daemon in the background. I'm going to port forward both port 80 as well as port 443. So those are the two ports that we're expecting traffic on. I'm going to add two things. I'm going to add a volume mount. So a Docker container by default is completely isolated from the file system of the host. We can add what's called a volume mount to allow access between those two systems. So in this case, I'm going to add a volume mount from Caddy data. So this will be a folder on the host system on that virtual machine. And I'm going to mount that into the container at the data directory. And so that is where Caddy is expecting to store its data. And that'll include things like that TLS config. We also want another volume mount at caddy/-config. We're going to mount that at config. And so these volume mounts basically allow us to, even if we bring this container up and down on the virtual machine, it'll be able to store off those certificates. If we're not careful when we're provisioning these certificates, we can get rate limited. And so by doing this, we'll store it off, and then the next time we bring it up, it'll already exist, and we won't have to retry that provisioning process, because otherwise it can take, I don't know, you can get rate limited, and then you got to wait 24 hours, and nobody wants to stay on the stream for that long. So I've got our two volume mounts, and then our image tag is going to be this tag right here. And I think, fingers crossed, but let's go ahead and try it. So it couldn't find it locally, so it went and found it on the public image from Docker Hub. It looks like we ran it here. And so let's get the logs from that like we did earlier. We see that it is attempting to get our key. I'm going to use the -- follow flag. And so that looks good. We got our certificate obtained successfully. Awesome. I do know that there's one change that we have to do, and this is kind of a quirk of how Cloudflare handles SSL. They have all these different modes. I have it set to flexible right now, which means it's encrypted from the browser to Cloudflare, but then it actually is unencrypted from Cloudflare to my server. My Caddy configuration is actually enforcing that requests must come in on HTTPS, so this would actually block it from happening. But the authentication with the server to get that certificate requires access on port 80. So that's why I have it set to flexible to start. Now I'll upgrade it to full, which means that we should be able to go here and load the page. And now anyone in the chat or on LinkedIn and YouTube can go to kodu.mysuperawesomesite.com, and we've got our presentation running live. So that got us through part 2. And now we can go and add CI/CD within GitHub Actions so that we can have any changes we make will automatically be reflected here at this public domain. Cool. I'm also going to make this a little easier to deal with. Actually, for now, I'm gonna go ahead and tear down this server because we're going to deploy to it separately from GitHub Actions. So I'm going to do docker ps, docker stop. Okay, so now the server's down. You won't be able to access it, but we will bring it back up shortly. Rather than SSH onto that machine and then execute commands, we can also pass a command to our SSH command that will get executed remotely. So I'm going to define a make target now, ssh-command, and so this is going to be pretty much the same, except now as the first argument, I'm going to pass some environment variable, cmd. So So whatever I whatever I set as my environment variable cmd will get executed on that machine. So for example, I can do make ssh command cmd equals ls. And so that'll run the list directory command on our remote machine. And we get back snap, which was the only contents of the directory that we were located in. And we actually saw that, I think, up here. If I scroll up, when I was on my machine, I think I had executed ls at one point. Yeah, so here when I had an SSH session on the machine, I executed ls, we got snap. Here when I executed it, I passed that one command and I get the result back locally. So it appears that make target is working. Now I want to create 2 more make targets. One is going to be to stop any existing container. So I can't just start all the containers at once because they would compete for the same ports. We have to have port 80 open and port 443 open. And so I'm going to make a make target now that I'll label stop remote. And this will recursively call make ssh command. And so what this is doing is it's actually calling this make target, and then we're going to pass it cmd equals, we're going to set this environment variable just in the context of this one shell invocation. And so by default, each line within a makefile is going to operate in an independent shell session. And so we're going to be able to set this environment variable independently for each of these commands. So I'll first do a docker pull image tag. And so what this is going to do is pull whatever version I specify in my tag onto that machine. That'll mean that there will be less downtime from the time that I stop the previous image to start the next image. Then I want to actually start my next, I need to stop the current running one. So I'll do make ssh command cmd. This will be docker stop. And then this is where the container name comes into play. So I haven't defined that yet, but we want to have a consistent name for a container. So I'll just define it here. It doesn't really matter what, as long as we use it consistently. So this will just be presentation Caddy. That's fine. And then we also then need to remove this container, basically to make room, because you can't have 2 containers with the same name on one system, even if that container is stopped. So now we'll do a make ssh command equals docker remove, and then we'll use this container name again. And so this, if I run stop remote, it will call these 3 things in succession. One additional change I'm going to make is to add a minus sign to each of these. And that just tells make, even if this returns a failed exit code, meaning that it didn't work, we still want to proceed with the others. And the reason this is important is that if we call these 2 commands right now, when there's no containers running on that VM, they're going to return an exit code of 1, meaning that the command failed. But that's okay. We actually still want to proceed because this step is going to be done as a cleanup step before we run containers each time. Cool. Then I'm going to do one more make target here. I'm going to call it run remote. And this is going to be, it's going to start by running that stop remote command. Make stop remote. So before we instantiate a new container with our updated image, we first want to call these 3 things to stop and clean up the old one. And then we're going to add a command to actually start our container. So this is going to be basically what we did manually on the virtual machine just a little while ago. So this will be ssh command cmd equals. And we can add new lines within make with a backslash. And so we'll do docker run. We can name our container using that container name. Great. We want to restart unless stopped. And so this means that if for whatever reason our container fails and dies on us, Docker will then go off and try to restart it for us. So that just gives us a little bit more robustness against failures. We want to run it in the background with that -d flag. We want to do all those port forwards that we did before, so 80 and 443. We want to add those 2 volume mounts, just like before. So Caddy data. You can probably hear dog in the background. Data. -b. This will be Caddy config.
I have to say, I love just the backslashes is something I always forget about. And my
Yeah.
files always look awful. So this looks really nice to read.
You got to keep it below 80 characters or your linter will whine at you. Although there aren't really many linters for makefiles, but it's definitely easier to process mentally when you got things lined up nicely. Okay. So I should now be able to run this make run remote command from my MacBook, and it will spin up a new container on the VM. So let's give that a shot. Okay, so we got no errors out, and we got a image or a container ID from Docker. And so let's see what happens if we refresh here. Looks like it worked. Great. That was the one command I was worried about typoing, because there's all those gnarly configs. But how are we doing on our checklist? Yeah, I think we're good to move on to creating a GitHub action. And so GitHub Actions is one of many continuous integration, continuous delivery tools. And what it allows you to do is effectively automate things based on any trigger event within GitHub. So that could be pushing to the main branch. That could be opening a pull request. That could be adding a tag. So any event within GitHub, you can generally have a trigger that will instantiate a workflow. And then within that workflow, we can define whatever we want. Our workflow is going to build our image. It's going to push it to Docker Hub. And then it's going to start that new image, a container using that new image on our virtual machine. And so the way that we actually define one of these workflows is we add a .github directory, and then within that we add a workflows directory. This is where GitHub is going to look for any action file. Within the workflows directory, any file that is a YAML file will be interpreted as a workflow. So I'm going to call it something like build, push, deploy, keep it simple. And we are going to do a few things. The first thing we're going to do is just give it a name, build, push, deploy, presentation, site. We then need to define when this workflow is going to be triggered. So we say on push. So anytime we push to our main branch, we want this workflow to be triggered. If we had multiple environments set up, let's say a staging environment and a production environment, we would likely have 2 different triggers here. We might say every time we push to the main branch, let's trigger a deployment to staging, but don't deploy to production unless we have a tagged version release. And so we would be looking at the tag numbers and saying, is this a release version? Then we would go ahead and push to deployment. So that's the model that I've worked with a lot of companies, is every time you merge to main, you get a new version on staging automatically, but then you don't deploy to production until you tag a release, and then you'll get that production version. Within this workflow file, now we can define any number of jobs. We're just going to have one job, and we're going to call it build, push, deploy. Getting real creative here. And then within here, we can add a name for our job. This is the internal name. This is the sort of human readable, nice name here. So it doesn't really matter. We specify what machine type or basically what environment this is going to run on. There's a number of options within GitHub Actions. I'm going to use Ubuntu latest. And so because this is a Unix-based system and my MacBook is a Unix-based system, we're going to have a lot of nice overlap where our workflow file is not going to have a lot of logic in it. We're actually just going to call our make targets just like we did on our local system within this workflow. There are two things, though, that we need to do before we can actually call those make targets. And that is to authenticate within this environment both to Docker Hub as well as our virtual machine. And so the way that we do that, I found two actions in the GitHub Actions marketplace. So that's one of my favorite things about GitHub Actions, is that they have tons of publicly available actions that anyone can add to here. And so you can find all sorts of things that will get you started and make it much faster to develop your workflows. In this case, I found one called SSH key action. Let me find it here. This one, I think, is the one that I'm using. And so it handles taking an SSH key and configuring the Ubuntu operating system and the SSH client on that operating system to use that key. And so that's the one I'm going to use here. In order to use this, we have to provide it with two things. We need to provide it with the key itself, and we need to provide it with a list of known hosts. So remember when I SSH'd into that VM on my system, it asked me whether I wanted to accept that new key fingerprint of my virtual machine. I said yes. But because within this workflow we don't have that interactivity, we need to ahead of time add our known hosts to this action. And so I'm going to go ahead and do that. I actually ahead of time went and let me just find intro DevOps webinar. So I have this GitHub repo set up. It doesn't have my code in it yet. It just has sort of the baseline markdown file that we started with here. I did go ahead and precede these secrets. And so this is how you pass sensitive information into these workflows. I added a Docker Hub token, so that's how I'm going to authenticate to Docker Hub. I added my Docker Hub username, and I added an SSH key here. I also need to add that known hosts secret so that that action can then properly configure SSH to be able to connect to my machine. And so in order to do that, I actually need to run this SSH key scan command. So if I go here, SSH key scan, I want the RSA version, and now I need my IP address. And so this gives me essentially a fingerprint that identifies uniquely my virtual machine so that SSH doesn't think it's a man-in-the-middle attack happening when I actually SSH onto it. So I'm going to copy this code and put it into a secret in that repository. And it needs to be secrets.knownhosts. New repository secret. Known hosts. Paste that in. Add secret. Okay. And so now I should be able to use that action that I found before. So I'm going to create a step for it. Step. Oh, steps is going to be plural. My first step, I'm going to name install SSH key. It uses that action that I found, which we indicate like this. And then I need to specify those two secrets so that it is able to properly authenticate. Key and then known hosts. That should be good for that step. For the next step, I'm going to need to authenticate to Docker Hub. So we'll call this Docker Hub login. It's going to use, again, I found this action in the public repo or public marketplace for GitHub Actions, and it takes in the Docker Hub username and Docker Hub token as the two options here. And so we'll just do this. So that should be good for it to be able to authenticate. The next step, and this is a step that pretty much any workflow you have is going to use this step, check out. And we need to tell the workflow to check out the version of the code associated with the event that triggered the workflow. So here, this is an official GitHub action from GitHub. Check out v2. So this step will take the content of our repository and essentially do a shallow clone into this workflow. If you need more versions, you can configure this specifically to go off and get however many versions of your history. But for this purpose, having just the current commit is just fine. And then we're going to have 3 more steps. We're going to have build. We're going to have push. We're going to have deploy. You can just define a bash command or a shell command to run here. And so I'm going to do that like this, make build production. And so this is where making that makefile is going to start really paying dividends, right? We defined all these commands. It's going to take care of all of our tagging, all of our configuration in terms of what IP address. That's all contained within our source code, so we don't need to worry about it. So we're here, make build production, that should be fine. Then we're going to do make push production. All right. And then I believe I called it make run remote. Let's make it make run production for consistency's sake. So I'll make this that should be fine. The one thing that I don't like about the current setup is that my image tag is hard-coded to latest. Ideally, we want to think about these container images as being immutable. They contain one version of the code and should only contain that one version and never be modified. There's nothing that technically prevents us from pushing to this latest tag over and over, but it's much better practice if we modify that so that each tag is unique. We could either do that by versioning with like v0.0.1. The way that I'm going to do it actually is to do, within GitHub Actions, there's a default environment variable, GitHub SHA, I believe it is. I believe it's GitHub _ SHA. Yeah, so we can just do GitHub _ SHA. So that'll be the commit hash of the commit that triggered this workflow. Because we also want this to not fail locally, where this environment variable doesn't exist, I'm going to do a little bit of a hack here and just say GitHub _ SHA. And then if I use the question mark equal sign, that means if the environment variable does not exist in my current environment, then set it to whatever value I put here. And so I'm going to put latest here. And so that way, on our local system, when we don't have this environment variable defined, we'll fall back to that latest tag, which is fine for doing local development. Okay, but when we run it within GitHub Actions, this will be equal to the commit hash, which enables us to have a different version each time and enables us to treat those container images as immutable. I think, let's go ahead and give this a shot. Who knows if it's going to work or not. If not, we'll go in and debug on the fly. But basically, we're going to commit everything. It's fine. Why did my... Why did that not get picked up?
I'm curious to see now if this works in one go as well, because it will be the smoothest
that would be a
presentation
miracle
I've ever seen. Yeah.
But right now, Git is it's not even seeing. Okay, there it's seeing it. Git add -a. Let's okay, looks like everything's added. We're just gonna do git commit.
DevOpsify, is that a technical term?
Yes, it is. So we just committed everything and pushed it. So if we look here at code, we now have all of our code. We've got our GitHub workflows. We go to Actions. Okay, we got an X. That means it did not work on our first try. No runner matching specified labels. Did I not include a dash or something? Ubuntu dash latest, is that right? Yeah, I think I needed a dash there. So fix runs on version. Clean up some of these old ones.
We got it in the chat saying it's not real development if there's no debugging. It's how everyone wants to see a mistake or two, just so we can, so everyone can relate.
I mean, the truth is, I've done this same presentation before, so I have the code working, and I can always cheat if I have to. So don't think this is how it really works in real life, that it worked the first try. You can see here, these older builds were from a previous presentation, and then the morning before this one, I went in and just wiped all the code and started back from that scratch base presentation. But it looks like we are now running. It's a good sign. Nice. It's better than before. I'll zoom in one here. Oop, failed. Failed to down. These little typos. I believe it is actions, not action singular. So we're gonna try that one. Oop. Third time's the charm. What do we think?
Yeah, you've got this. Somebody said it's like real singing versus lip syncing.
Okay, here we go. Third time is the charm. Oh, here we go. We are doing things. So,
ooh, this is fast. This is going really fast.
Yeah, so let me just minimize these guys. So it looks like we successfully added our SSH key. We logged into GitHub. It really wants me to see stuff. Too fast. Can't keep up. We then logged into Docker successfully. We checked out our code. We built it. Looks like that worked. It downloaded the base image, added our configuration, etc. Tagged it with, remember we added that GitHub SHA, so this was the commit hash of our latest commit, so that is good. We then pushed it. Looks like it successfully went. Let's go over to Docker Hub and confirm that. Kodu intro to DevOps. And we see this is the tag. So we successfully tagged that version and pushed it. We then ran our deploy command, and it pulled that version from Docker Hub, ran our stop cleanup stuff, then ran our Docker command, gave us a Docker image. And so I think if we go to kodu.mysuperawesomesite remark.js.com, we get a live presentation. And so now let's test our CI/CD by making a change and then checking it in. We did notice that when we were going through this presentation, this was incorrect, right? So we're going to go fix that. We're going to go back here into our... Go ahead.
I have a question for me this time. When you're using or tagging the Docker files via the commit hash, is that seen as a decent practice or a standard?
Yes, that's definitely the best practice. If you are building based on commits, then that is a perfect unique identifier to use. When we go to then build those production images based on a version, a release tag, those release tags are also unique, so I would use that as my tag. So I would have all these commit hashes on staging, and then when I have production, it would be Sid Palace / Kodu intro to DevOps : v1.1.0 or whatever that release tag would be.
Nice. That's very cool.
So I just updated my markdown file for that erroneous slide now that we have our new updated URL here. So I will add that. Check. Git push. And then ideally, we can just keep chatting here, and then we'll refresh the page in a few minutes once this action finishes, and we should get an updated version. And so in addition to building and pushing, normally you would want to add your unit tests and your integration tests within a workflow like this. Like I said, you would split out a staging and production environment. You can do all sorts of things with GitHub Actions or whatever CI tool you're working with.
It's very interesting. I didn't see things work this smoothly before, really, because I've always been lucky enough for being able to have somebody else help me through these things as well. So it's really nice to see how quickly you can get operational.
Yeah, I think the key things to making it work really quickly are these helper actions, like going in and mucking with setting up your shell script to add the SSH key and configure OpenSSH correctly. Like, I didn't have to do that, right? All I needed to do was find an action that was highly rated and I was confident wasn't going to go hijack my SSH key, and give it the information it needed within those secrets, and then boom, I was done. Same thing for this one. I really like this approach of sort of having these scripts or make targets that I use locally that I can then repurpose within my workflow. And so this same exact workflow could be used for almost any Docker deployment onto DigitalOcean, right? I can put whatever I want. Like, this is the actual implementation of build production is an implementation detail that the workflow doesn't care about.
Yeah, it's super powerful. Like, there's very few lines of code here, and we have lots of things happening. That's what's amazing here, because I think for a lot of developers, we know how to build some apps and then just not know how to support them. And with a CI/CD, it just means you can really just drive on with development. So, you need to set these things up for a few days, and then you're ready to develop at rapid pace.
Definitely. I mean, even with a personal site where I'm only deploying every so often, I'll always go through and set something up like this, because otherwise, 2 months later, I'll want to publish a new post or make an update, and then I'll be digging through my code trying to see, what did I do? How do I deploy this thing? What configurations need to be made? It's so much nicer to just say, I'm going to make my update and push it, and then 2 minutes later, we'll be able to see it reflected. So if I refresh this page now, we get that update in the browser just like we expected. So it appears that everything is working as planned, and we got a green check mark, which is always a good sign.
Nice.
Awesome. So that is pretty much all I had for today. So I'm happy to continue the dialogue and answer questions from the chat, questions from you, and just keep on talking.
Yeah, for sure. I definitely have a couple questions anyway. I think this potentially, if it's the first time people ever looked at deployments and things like that, might be a little bit overwhelming, and they might need to watch this a couple times to really see all the different things you've done. And that's totally understandable. I know the first time I dived into this stuff, it just took a lot of time and repeat until it kind of embedded. into my brain. And I guess on that kind of note, you're a pro at this stuff, and I think a lot of people would wonder,
allegedly,
what do they do? Allegedly, right? You're allegedly a professional. I can tell by that moving background. But what would you tell beginners to focus on? What is, like, do you think was the best fundamentals you picked up to become good at doing this at scale?
Yeah, I think the key is to not try to boil the ocean right off the start. Like, if you go in and you say, I'm going to build my portfolio project, and it's going to be Dockerized, it's going to be the infrastructure set up as code, we're going to deploy multiple replicas of our application onto Kubernetes. That's just too much to get started, right? Anyone would be overwhelmed. So I think picking which piece of that puzzle you want to really focus on and say, okay, for this project, I'm going to use Terraform to set up the virtual machine. And everything else I'm going to use kind of how I've done in the past. I'm going to not worry about Docker. I'm going to build my Node.js app just using Node directly. I'm going to SSH onto the machine once it exists and run my git clone command and then Node npm start on the machine itself. And so I think tackling it one piece at a time. And that would allow you to learn Terraform. And then maybe on your next one you say, okay, now I'm gonna forget the Terraform thing and I'm gonna focus on containerization, and I'm gonna take my application and I'm gonna build a Docker container for it and get it running. And so I think breaking down the problem to avoid getting overwhelmed is really what I would suggest as the best approach there.
Sure, excellent. And so other than obviously the DevOps Directive YouTube channel being the #1 place to go if you want to get information on how to do this stuff, what would be your highest rated kind of learning resources for people doing this if they didn't want to just like grind through the docs?
Yeah, I mean, I think that is probably, you hinted at it, but just going to the documentation for whatever tool you're using is usually the best place to start. It can feel overwhelming for a beginner, but definitely the documentation is the most efficient way to get up to speed. I think if you are lost in the documentation, having a video guide, a tutorial, can help bring to light some of the pieces that you might be missing. So sometimes that can be a good starting point, although I think people tend to use it as a crutch. They get overwhelmed and they immediately want to go have their hand held all the way along the path to success, and you lose out on the ability to think for yourself if you follow too many tutorials without modifying them. So I think go to the docs, at least spend a little bit of time trying to internalize and figure things out before you reach out to a nicer Goldilocks path that a tutorialized video might provide.
Yeah, it makes sense. And I think, kind of speaking on that crutch, I think Praveen had a great comment here. Like, new platforms like Vercel have made this really easy for front-end developers. Would you see any like proceed with caution by always having these tools readily available to us, or do you think it's just nice to have and you should just fly with it? And this might be a controversial opinion. You're capable of setting the world on fire here, so.
No, I think Jamstack and tools like Vercel for front-end only applications are super powerful. If you don't need an API server, don't have it by any means. Like the fewer blocks in your architecture diagram that you control, the easier it will be to understand and to iterate. There are just certain things where you need a server. You can't just get away with the client side, and so in those cases you have to dive down and get dirty. You can go with a platform offering like Heroku that helps to ease the process of getting set up. I think if I were starting a startup right now, I would probably build on some platform as a service offering like Heroku to get started. And then once that became costly, initially the free tiers are quite nice for a lot of these platforms and quite inexpensive. But as you start to grow, you can start to feel a little bit of pain in some of the the platform as a service offerings, whether that's Heroku or App Engine on Google Cloud or Beanstalk, I think is an AWS one. But sort of use that and focus on iterating on the product, because that's what matters early on. And then as those systems start to break down, then you can start to take a better look at your DevOps and infrastructure practices and whether you need to migrate to something a little more homegrown or move to Kubernetes or what have you.
This might be, again, more of a personal question for me as well. Is there symptoms usually that you see that means you should probably invest more time in DevOps or, taking the time? Because obviously these things, especially when you have an existing application, it's difficult. It can be a costly and timely thing to do. But is there a certain point where you're just like, you know what, this is actually, it just needs to be done?
Yeah, I think just honestly assessing the pain that you're feeling from things like manual testing or manual deployments. If there's anything in your developer workflow that is manual, and inevitably those things start to creep in of, oh, I just click these 3 boxes and then I have a new server. Oh, I do these 3 things and then I have my tests run. I think just taking an assessment of how painful those are, and if the pain level is below some threshold, you say, just keep on keeping on, and we'll just make do with how it is. But then it reaches some threshold where you realize, okay, we have a team of 10 developers and they're wasting 30 minutes a day doing these types of activities. We should really invest time in fixing those so that that is not unproductive time that we could invest in product development.
Nice. And is there much difference, I suppose, in what you have tackled here with some application as there is to getting, say, a database spun up? Or is it a completely different scenario?
So Docker and containers in general, you can operate databases within them. This is a somewhat controversial topic that people will debate on, of whether or not you should run your database in a container. Containers make so much sense for applications that you're iterating on and changing and you're bringing up and down because they're this lightweight package that you can deploy and replicate, etc. A database is something that if you're modifying the version of your database or bringing it up and down more than once a quarter, you're probably doing something pretty wrong, right? I mean, you're running migrations to change the schema and such, but you're not upgrading the major version of your database once a week. You're not moving your database from one cloud provider to another once a week. And so because of that, a container isn't necessarily, you don't really get that many benefits from running in a container, but you do then have this sort of additional layer of complexity and abstraction around it. So oftentimes what I suggest especially for startups, when you don't have a dedicated database admin who really knows the ins and outs of your particular database of choice, is to use one of the hosted offerings, whether that's a Cloud SQL from Google or a RDS from Amazon. DigitalOcean has hosted databases, and that kind of offloads a lot of the management of that database system onto the cloud provider. And sure, they're not going to have everything perfectly fine-tuned and hyper-optimized, but hopefully they have some sane set of initial configuration options that get you pretty far.
Yeah, I think that's important, because I think a lot of people get concerned, especially earlier on in their career, that they're leaning on these vendors for their scaling and things. And I think it's okay. As you said, there's people that their job is just scaling databases and everything else. So leaning on those platforms, like I use Atlas a lot by MongoDB. And it's fantastic, and I see a lot. I've often got queries saying, but you wouldn't really use that for a production application or something. I was like, I'd absolutely use it for a production application. It does everything I need.
Yeah, and you pay a little bit of a premium in terms of if you were operating it yourself, the compute cost would be 50% lower maybe, but what you're paying for is the person on the other side of that transaction who works at Atlas, who's getting a salary from Atlas, who is paid to make sure that they are configuring their systems appropriately. If you don't have that person or expertise in-house, then I think that's a fair trade in a lot of cases, and one that many companies are willing to make, is pay a premium on the compute, but instead get a little bit of assistance in terms of how to operate with best practices.
For sure, and I think that's it. Like, you're going to be paying somebody a salary, or you can pay somebody or a service to do these things for you. Either that, or you become a wizard yourself, and it's very hard to do all these things. I forgot we weren't. We were still sharing the screen there.
I had that beautiful question slide up.
Excellent. I think you've a lot of people you've scared them away, have you? Because there's still there's a good few people watching here, but they don't want to ask questions. I think, look, this is by far, and I mean this sincerely, because notoriously on my streams, things go horribly wrong. I didn't want to tell you that before I invited you, so that would scare off anyone. But it's been excellent. I'm shocked with how smooth things went and the amount you squeezed into this. Like, I'm definitely going to go and watch this back myself, because there's just a wealth of knowledge. And is the code going to be available afterwards that we can grab and use?
That Sid Palace Intro to DevOps webinar repo is public. If I give this talk again in the future, I'll probably wipe it out, but you could always find I think I tagged a version at the last presentation that I gave, v 1.0.0 maybe.
I might fork it and put it on the Kodu repo if you don't mind.
Yeah, that's perfect. I should actually add a license to make that more clear. Anyone who has a repo that's open source, you should add a license to it so that people know whether or not they can use that code legally. Otherwise, it makes it confusing, and so it's much better just to have a permissible license, as long as that's what you want, available in the root of your repo.
Nice. David said, great presentation. It went too well. I think we were all suspicious. Anyone that's been here for my meetups before are used to chaos. So
well, like excellent. I said, I got it all working ahead of time, and I've given this webinar once before. So the first time programming it certainly didn't go that smoothly.
For sure. And Sid, any picks as such? Like, is there any books or things you're looking at the moment? It doesn't have to be DevOps related. Just things you like at the moment, things you think people should go and look at or do.
I am reading a book called Best Practices for Kubernetes, which is very good. I've worked with Kubernetes quite a bit, and now it is helping to solidify some vague ideas I had around how to handle certain situations and make them into concrete practices to follow. So that's a very good one if you're working with Kubernetes. Another book that I haven't started yet, but I'm hoping to start, is called Data Intensive Systems. An
O'Reilly book.
Yeah, by Martin Klepperman. So that I read a little bit of that, kind of the intro, and I'm planning to buy that soon. But it looks very good. A lot of the work I do. Wish list. Yeah, a lot of the work I do is with startups who have large data processing workloads. So at the company I was at previously, there was a ton of machine learning work around OCR and then interpretation of the results of that OCR and trying to make sense of it. And so I think that's one example of a very data intensive system. One of the companies I work with now is doing lots of simulations in the crypto world. So simulating these different crypto protocols and understanding market risk. And so I've helped them migrate a lot of their architecture onto a platform called Kubeflow. And so we're working with these massively parallel simulations on that front. And so, yeah, I think that book would be a valuable one to read in the near future.
Nice. I think I have two more things, and that is, Sean here has any recommended courses?
Not recommended courses. There is a site called roadmaps.sh that has a bunch of different roadmaps. Roadmap singular, sorry, .sh.
What was that again?
It's roadmap.sh. And so I think you've seen probably some of these on YouTube, but this guy put together a couple of really nice but overwhelming paths to front end, full stack, and he has a DevOps one. And so this can be a nice way to at least know what pieces people should be looking at and thinking about. Like I said, it's pretty overwhelming. There's so many pieces to it, but at least you can look at where different buzzwords that you've heard fit into the into the puzzle. And actually, I'm considering sort of what direction I want to go with DevOps Directive video content, and have thought about sort of trying to do a full series where I take a walk through each of these topics and give just an intro, maybe an intro and then an intermediate for each of them, walking down the path. But TBD whether that comes to fruition or not. Too many ideas, not enough time.
Can people reach out to you on Twitter or that if they have any questions?
Yep. So my Twitter handle is just Sid Palace, no space. And they can find me there. They can find me on LinkedIn. And then I have a Discord as well that you can find on most of my YouTube videos. I'll add a link. And so Discord is probably the best place for sort of in-depth technical discussions around this stuff. But happy to point you there if you find me on Twitter or LinkedIn as well.
I didn't realize you had a Discord, so I'm going to join that myself now to annoy you some more.
It's brand new, yeah. I started it a little while ago. I think I have maybe 20 or 25 people in there, but we've had some good discussions. I saw Chris's comment from earlier. Chris is one of the active members of the Discord, so yeah. That's
excellent. And I guess, I know you didn't really want to plug it earlier because you said I don't want to plug too many things, but I like to push other people to plug themselves probably too much. If people want to find you for work or for queries or to get a quote or even to just talk about a problem for their business, where would they go?
Sure. So DevOpsDirective.com is my technical blog site. I'm adding a page there around my consulting work. It's in progress now with some testimonials from current and past clients. So going there to sort of get a sense of the type of things that I work on and write about, or just LinkedIn is fine as well if people want to reach out.
Excellent. Great. Look, Sid, it was excellent having you. And I think before you get bombarded with more questions, we might end it here.
Sounds good.
Excellent. All right, everyone. Until next time, happy coding.